Good afternoon and welcome to the last problem solving session for this course. So we will wait for 2 to 3 minutes for others to join, and if okay, let's start. So first, let me share my screen. So good afternoon and welcome to the week 12 problem solving session on of the course Environmental Chemistry. The course instructor is Professor Bhanu Prakash Velanki from Department of Civil Engineering, IIT Roorkee. And I am one of the TA for this course. My name is Asma Parveen, and I am a PhD scholar in Civil Engineering Department at IIT Kanpur. So basically, the last module was about uh, redox potentials and how to find, and it was about Nernst equation, P, log C graphs, and also about the E pH area predominance graph, in which we see at a particular pH which of the form of the compound, which of the species of the compound is dominant based on the pE. So let's start with the solving the previous year assignment question. So let's go to the questions. So here is the first question. So the question is, given the following two half reactions. So two half reactions are given and their corresponding E naught of the reactions are given. We have to find out what is E naught for the half reaction representing the oxidation of HOCl to ClO minus 3. So we have to do a very small manipulation, that is addition and subtraction of the two reactions to get the E naught for the oxidation of HOCl to ClO3 minus. So to solve this question, I will give you 5 minutes. Just go through the question, try to solve it and write the correct value in the chat box, because there are no options in this question. So please write your numerical value which you are getting in the chat box. any answer till now. So let's see how to solve this question. It is a pretty straightforward question in which we have been given two reactions and we have to find out the E naught for the a particular reaction. So let's see how to solve this question. So we have to find out the E naught for the half reaction representing oxidation of HOCl to ClO minus 3. So oxidation of HOCl to ClO minus 3, it means that ClO3 minus is getting reduced to HOCl. So the first reaction here is ClO minus 3 plus 6 electrons plus 6H plus, it's giving Cl minus plus 3H2O. And the E naught for this reaction is 1.446 volt. And we will reverse the second reaction. So we will write the product in the reactant side, that is Cl minus plus H2O. It will it will give us HOCl plus 2 electrons plus H plus. Now since we have reversed the reaction, also the E naught will be reversed in sign. The value will be same, only the sign will be negative. Here the earlier E naught was given as plus 1.481. Now since we have reversed the reaction, it will be minus 1.481 volt. Okay, now we have to just add these two reactions. Also from the Nernst equation, we know that E naught for any particular reaction does not depend upon the number of electrons transferred between two reactions. So we can simply add the E naught value for these two reactions, and overall E naught will be, let's first add these two reactions. So what we will have to do, let's suppose first this is 1 and this is 2. So to balance the electrons, we will multiply reaction 2 by 3. So what we have to do, we have to add, let's write it, reaction 1 plus 3 times of reaction 2. So what we will get is ClO minus 3 plus 6H plus, okay, leave it. So on the product side, it will be Cl minus will get cancelled out. So 3 minus 1 H2O, it will be 2 H2O. So 2 H2O. 3 to just 6 and 6 electrons will also be cancelled out, and it will be 3 HOCl and 3 electrons, 3H plus 6H plus, so it will be 3H plus and 3 minus 3, so H2O will also be cancelled out. So this is the final equation. Let's see, is it balanced or not? No, it's not balanced. Okay, so 3 Cl minus and 1 Cl minus, so we will get so I think the reaction is not balanced. So there will be no H2O because 3H2O and 3H2O, it will cancel out. Okay, now the reaction is balanced. Also, Cl minus plus 3Cl minus, we will have 2Cl minus in the reactant side. So 2 plus 1, 3Cl, 3Cl, 1 oxygen, 3H plus and 3H plus. Also the charge plus 3 minus 2, that will be plus 1. Charge is not balanced. I don't know why. Okay, we will see this question at the end. Let's just, so even though we are having I am having trouble in balancing this question, but we know that the from Nernst equation E naught value does not depend upon the number of electrons, but because it is given, E naught value is given per electron, so the overall E naught for the reaction will be 1.446. We have just added the reaction plus minus 1.481. So overall E naught value we are getting it as minus 0.035 volt. So I'll see the what problem I'm having in balancing this question, and we'll discuss the balancing at the end. So this is the E naught for the half reaction representing the oxidation of HOCl to ClO minus 3. So let's move to the next question. So the question is, silver jewelry is usually kept in airtight pouches and strictly away from rubber bands. If exposed to either of these, it tends to tarnish. Why is it so? So four options are given. The first one is sulfur present in rubber or air oxidizes the silver 0 to Ag2S. Silver form rust due to moisture. C. Silver has high reducing tendency. Or D. Carbon dioxide in air dissolved with moisture develops acidic condition on the surface. So please try to solve this question. I'll give you 5 minutes. Just take your time and please participate in solving the questions. Um, please solve the question and write the correct option in the chat box. Okay, I got one answer as A. So A is the correct option. So what happens is the sulfur which is present in rubber band or air, it oxidizes the silver to Ag2S, and due to this the tarnishing of the silver takes place. And if you want to remove the tarnish, then let me write the reaction first. So what happens? Silver, that is Ag, solid, it reacts with H2S, that is hydrogen sulfide gas, and it forms Ag2S solid. This is the tarnish along with hydrogen gas. So first option is correct, that sulfur present in rubber or air oxidizes the Ag to Ag2S, due to which tarnishing of silver takes place. And if we want to remove the tarnishing, then we can react aluminium to form aluminium sulfide, and correspondingly we will get silver. So for that reaction, suppose if we have Ag2S solid and we add aluminium solid, then this will give us silver in the pure form, solid form, along with aluminium sulfide will be formed. So tarnishing of silver is due to sulfur in the air or rubber band. So let's move to the next question. I think the next question. Oh, okay. Let's first go to the previous one, in which I was having problem in balancing, because there is a slight pre- ed- formatting error. It is ClO3 minus. It is not ClO minus 3. It is ClO3 minus. So 3 minus. So it will be 3 minus. Now if we see, we can see that the charge is balanced, because plus 3 and here minus 3, it is balanced, and on the reactant side it is 0. Here the charge is 0 and here also the charge is 0. So this reaction is balanced. So let's move to the next question. So it is also a numerical question. What is the voltage of a voltaic cell at standard conditions based on this reaction? Is the reaction spontaneous as written? So reaction is not here. Okay, let me write the reaction here. So the reaction is 2NO, this nitrate, plus 8H plus 3Cu. It is forming 2NO plus 4H2O plus 3Cu2 plus. So we have to find out the voltage at standard conditions, and we also have to state whether the reaction is spontaneous or not. So to solve this question, I'll give you 5 minutes. Okay, I have to provide the EH naught for each reaction. So first, what you do, first you identify which one the oxidation and reduction couples, and then we will proceed. So to identify which one is the oxidant and which one is the reductant. So I'll give you 2 minutes for that, and then further I'll provide you the EH naught values. Okay, let me provide the EH naught values. So for reduction of nitrate, NO3 minus plus 4H plus 3 electron, EH naught at standard conditions is 0.96 volt. And for reduction of Cu2 plus to Cu, EH naught is 0.34 volt. So these two are the reduction reactions, and based on the reaction which is given, we have to find out what is the standard voltage of this cell and also whether the reaction is spontaneous or not. So I'll give you 5 minutes. Just take your time and write the correct option in the chat box. So I got one answer as D, and D is the correct answer. So let's see how to solve this question. So I have provided the EH naught values at standard condition. So we have been given that nitrate is getting reduced to NO, and also the copper is getting oxidized to Cu2 plus. So simply what I have to do, I have to just reverse this reaction and add. Also, we have to find out the EH naught of the cell, and we know that EH naught is given for per mole of electron. So if we will balance the electrons by multiplying these two reactions, then it will not affect the value of EH naught. So first let's balance the reaction. So anyhow the balanced reaction is given at the here only, that we have to, so it is 3 electrons, so it will be into 3, and it will be, so first we have to reverse this because the copper is getting oxidized, so it will be Cu getting oxidized to Cu2 plus and releasing 2 electrons, and so the EH naught for this reaction will be minus 0.34 volts because we have reversed the reaction, and also it's oxidation reaction, so its EH naught value will be negative. Now what we have to do is we have to balance these two reactions, that is this reaction and this reaction. So what we will do, we will multiply it by 3 and multiply it by 2. So let's give it reaction number 1 and reaction number 2. So 2 into reaction 1 plus 3 into reaction 2. So then we will get 2 nitrate plus 8H plus 3Cu. It will give us 2NO and 4H2O plus 3Cu2 plus. Now this reaction is similar to the given reaction. So we have to find out the EH for the overall cell. So EH naught overall, it will be EH naught 1 plus EH naught for the second reaction. So the first reaction EH naught value is 0.96 plus, for the second reaction it is minus 0.34. So overall we are getting the value of 0.62. Also we know that if EH naught will be positive, then the reaction will be spontaneous, and if it will be negative, then reaction will be non-spontaneous. It is just reverse of what is Gibbs free energy. We know that if the Gibbs free energy of the reaction is negative, then it will be spontaneous, and if it is positive, then it will be non-spontaneous. So it is just opposite of that. Since EH naught is positive, okay, let me go to the next slide. Since EH is greater than 0, it means that the reaction is spontaneous. So I hope this question is clear. If you have any doubt, you can just unmute yourself and ask. Okay, let's move to the next question. So it is a multiple choice question. We have to select the correct method used for controlling corrosion in metals. Okay, there is more than one option which is correct. So let me see, because the screen is not getting changed. Okay, now it has changed. So we have, so we have to select the methods used for controlling corrosion in metals. So there is more than one option which may be correct. So first option is insulating metal, that is anode, and oxygen is cathode. For example, the paint. Next is applying a potential to avoid a thermodynamically favorable reaction. Option C is scratching the surface to create active sites for reaction. And last is using another metal to sacrifice it rather than the metal of concern. So these four are the options, and we have to find out which of these options are used for controlling corrosion in metal. So again, I'll give you 5 minutes. Just go through it and write the correct options, because there may be chances are there is more than one option which is correct. So just take your time and write your option in the chat box. Sorry, I got disconnected. So this is the question. We have to find out the correct option. Okay, let's see which of the following are the correct options. So first one is insulating metal and oxygen, for example, paint. Generally, we apply paint on the surface of the metals to prevent the contact of the metal from the atmosphere and the moisture and oxygen in the atmosphere and prevents its corrosion. So first option is correct. So next is applying a potential to avoid a thermodynamically favorable reaction. So this is also correct. If you apply some potential that makes the corrosion reaction unfavorable, then it will not happen and the metal will be protected. Next is scratching the surface to create active sites for reaction. So if we will scratch the surface, then there will be more roughness on the surface and there will be more active sites on which the reaction can take place. So this will favor the corrosion of metals rather than protecting the metals. So this option is not correct. And the last one is using another metal to sacrifice it rather than the metal of concern. Generally, we paint some other metals on the surface of the metal to protect it from corrosion. So option A, B and D are the correct options. So A, B and D. So these three are the correct options. Only C is incorrect. So let's move to the next question. Again, we have to choose the incorrect statements among the following. So there can be more than one options which can be correct. So first one is anode is the terminal at which reduction occurs and at cathode oxidation. Next is galvanic cells are the cells requiring external current required to introduce a non-spontaneous reaction, and electrolytic cells are the cells that generate current due to spontaneous reaction. So this was the definition for galvanic cell and electrolytic cell. Option C is standard hydrogen electrode has hydrogen gas at 1 atm with electrode potential of 0 volt. Next is in nature, the presence of other reactions apart from redox reaction like precipitation, acid base interaction and complexation does not affect the direction of reaction. And last is the hydrogen fuel cell generates electrical energy due to oxidation of hydrogen to H2O rather than combustion. So these five are the options which statements which have been given, and we have to find out which of the following are incorrect. So I'll give you 5 minutes because there are five statements. Just read the statements and think about it. It was in the lecture slides, and find out which was the incorrect statement and just write your answer in the chat box. So I got one answer as A. As I have told, there are more than one option which can be correct. So please rethink about this question and read all the statements and then write your answer in the chat box. Okay, let's see which of the statements are incorrect. So first one is anode is the terminal at which reduction occurs and at cathode oxidation occurs. This is not correct because at anode oxidation occurs and at cathode reduction occurs. So A is not correct. So we have to mark the incorrect option. So A. Next one is galvanic cell are the cell requiring external current to induce a non-spontaneous reaction. So this is also not correct because galvanic cells are the cells which produce current flow due to spontaneous reaction. And in that, electrolytic cells are cells that generate current due to spontaneous reaction. So electrolytic cells are the cells which require external current to induce a non-spontaneous reaction spontaneous. So B is also not correct. Next one is standard hydrogen electrode has hydrogen gas at 1 atm with electrode potential as 0 volt. So this is the correct option. Sorry, this statement is correct. This is not the incorrect statement. Next one is in nature, the presence of other reactions apart from redox reaction like precipitation, acid-base interaction, and complexation don't affect the direction of reaction. So this statement is wrong because in nature every reaction will which takes place like acid base reaction or precipitation, complexation, everything will affect the redox reaction. So this is also incorrect. And the last statement is the hydrogen fuel cell generate electrical energy due to oxidation of hydrogen to H2 rather than combustion. So this is the correct option. The statement is correct that hydrogen cell is energy is generated by reduction of hydrogen. So we have three incorrect options, that is A, B and D. So only two is correct, that is C and E. So let's move to the next question. So if you have any doubt, just unmute yourself and ask. Otherwise, we'll move to next question. Okay, let's move to the next question. Also, if you have any doubt related to any of the problem sets or any part in the lecture that you didn't understand or you want and you want me to explain, then you can just please ask, unmute yourself and you can ask. Also, there will be one more lecture session. I think there will be one session of 1 hour on Monday, that is tomorrow from 7 p.m. to 8 p.m., where most probably we'll be discussing about what we have covered overall in this week 12 course. Also, we will try to solve one or two small numericals, and that's all will be for this course. And then you all have exam, I think, on 29th of October. So let's move to the next question. So the statement given is combined for question number 6 and 7. The statement is: nitrification is an important process in the nitrogen cycle. Ammonia formed by the process of ammonification gets oxidized to nitrite, and then it is getting oxidized to nitrate by the process of nitrification. Some reactions may not be available in standard books, and hence it is required of you to solve the question from basics of thermodynamics. Okay, no problem. Determine the standard potential of the following nitrification reaction. So ammonia is getting oxidized to nitrate, and we have to find out the standard potential for this reaction. Okay, I think we need some values. Okay, first we need to find out the delta G of the reaction. So let me give you the values for all delta G naught of formation of these reactions. So delta G naught of formation for nitrate, it is minus triple 1.3 kilojoules per mole. Delta G naught of formation for H plus is 0. For H2O, it is minus 237.18 kilojoules per mole. For ammonia, it is minus 25.57, and for oxygen aqueous, it is 16.32, all in kilojoules per mole. So this is the gives free energy of formation of these compounds which are given in the reaction, and we have to find out the standard potential. So we know that there is a relation between gives free energy, that is delta G, and EH of the cell, or sorry, EH of the reaction. So use that. Okay, I will give that relation. So we know that delta G of the reaction equals to minus n, that is number of electrons which is getting transferred. F is the Faraday constant, and delta EH, yani ki sorry, that is the overall uh, uh, cell potential of the reaction. So I have given you the values of delta G naught of formation of each of the compound, and also the relation. You just have to find out the delta G for overall reaction, and just put the everything in this reaction, and we can find out what is the EH naught of the reaction. So okay, I'll give you 5 minutes. Just take your time and do the calculation, and we'll see how to solve it. So I've also provided the Faraday constant, that is 96.5 kilojoules per volt. So just put down everything in the this formula and we can find out the value of delta EH of the reaction. Okay, let's see how to solve this question. So first we'll find out the Gibbs free energy of overall reaction. So it will be, we will add the delta G of formation of the reactant, sorry, product side, and subtract it with the summation of the reactant sides. So first is nitrate, so it is minus 1.3 kilojoules per mole. For H plus it is 0, so 0, plus for H2 it is minus 237.18. Now we have to add the reactant side and subtract it from the product side. For ammonia it is minus 225.57, plus there is 2 moles of oxygen, so we'll multiply 2 into 16.32. So after solving this, we are getting delta G as minus 355.55 kilojoules per mole. Now we have to find out the standard potential of this reaction. So I have given you this relation that delta G and how gives free energy and reduction potential are related. So let's find out. So delta EH will be minus delta G upon n number of electrons into Faraday constant. So let's go back. So here the number of electrons which will be transferred is not given. So we have to separate this overall reaction into reduction half cell and oxidation half cell, and we have to find out how many number of electrons are transferred between these two reactions. So let's do that. So let's first write oxidation half reaction. So in oxidation, ammonia is getting oxidized to nitrate. So now first we'll balance everything except hydrogen and oxygen. So nitrogen is balanced. Next we'll balance oxygen. So 3 oxygen in the product side. So we will add 3 H2O in the reactant side. And next we'll balance the number of H plus. So 3 to the 6 plus 3, 9H plus. And to balance the charge on both the sides, we will add 8 electrons. So everything is balanced. So next is the reduction half reaction. So oxygen aqueous, it is getting reduced to H2O. So first we'll balance oxygen. Next we have to balance hydrogen atom, so 4H plus, and finally we have to balance the charge, so 4 electrons. And to write the overall reaction, what we will have to do, let's assume this is 1 and this is 2. So to balance the number of electrons, we have to multiply the reaction 2 by 2. So it will be NH3 plus 3 is okay. So it will be 2O2. It will give us NO3 minus plus H plus and plus H2O. And while we are multiplying it by 2, that will be 4 to the 8 electrons and 8 electrons. So N is 8. So let's find out the delta EH. So it will be minus del G, it was 355.55, I guess, kilojoules per mole. Upon number of electrons which are transferred, it is 8, and Faraday constant I have given it as 96.5. So let's solve this and find out what value we are getting. Okay. Also, this is delta G was minus 355. So we are getting delta EH as 0.46 volt. So what was asked? So we have to find out the standard potential of the nitrification reaction, that is 0.46 volt. So let's move to the second part of this question. The question is, the nitrification process usually starts with ammonium rather than ammonia as solved in the previous question. What will be the standard potential if ammonium is present rather than ammonia? So we have to find out the standard potential if ammonium is present. So let me give you all the standard potential for the reaction. So for reduction of nitrate to ammonium, EH naught is 0.8, okay, 0.881 volts. And for reduction of O2 aqueous to H2O, EH naught is 1.272 volt. So I'll give you 5 minutes. Just take your time. It is a similar question like we have solved. I think in first or second question, it is similar to that. So I'll give you 5 minutes. Just take your time, do the calculations, and write the correct option or the correct value in the chat box. So let's see how to solve this question. So there is nitrification of ammonium to nitrate. So we will reverse the first reaction. So it will be NH4 plus 3H2O. It will get oxidized to nitrate plus 10H plus and 8 electrons. So EH naught value will also get reversed in terms of the sign. So it will be minus 0.881 volt. So we have to find out the standard potential for oxidation of ammonia. So it will be this reaction plus this reaction. Okay, so overall standard potential will be minus 0.881 plus 1.272. So let's solve this and find out what value we are getting. So we are getting 0.391 volt. So options are in millivolts, so it will be 391 volt. So B is the correct option here. So let's move to the next question. So the question is, what is the value of E for the half reaction? The half reaction and along with its concentration is given, and we have to find out what will be the reduction potential at the given stand condition and concentration. So the standard reduction potential is 1.508 volts. So this is the standard reduction potential. So we have to find out the reduction potential at given concentration of the species. So it is also based on, this question is based on Nust equation. So let me provide you what is Nust equation. It is EH equals to EH naught minus RT by NF ln Q. So this is the Nust equation. So we have to find out what is EH. Provided EH naught is given, we know what is T, R, number of electrons, Faraday constant, and also we know Q dash because the concentration of all the species are given. So we just have to put everything in this equation and we'll get the reduction potential of the reaction. So I'll give you 6 minutes for this question because we have to do a lot of calculation. So try to solve this question and write your answer in the chat box. Okay, let's see how to solve this question. So we have been given EH naught, that is 1.508, minus R, it will be 8.314. Temperature will take as 25 degrees centigrade as standard. So we will take temperature in kelvins, that is 298. Upon number of electrons involved is 5. Into Faraday constant, it will be 96.5 kilojoule per volt. So we will multiply it by 1000, because R is in 8.314 joule per Kelvin per mole. So F will also be in joules, into ln. So we have activity of Mn2 plus. We know activity of H2 will be 1, so we will not take that. So then MnO4 minus into H plus raised to the power of 8, and for electrons it is 1. So we will solve this. It will be 1.508. Okay, this will be the final values, and after solving this, we will get the E for the half cell as 1.44 volts. So it is a pretty straightforward question based on the Nernst equation, that we have been given the EH naught, and we have been given the concentration of all the species involved in the reaction, and we have to find out the reduction potential at given conditions. So let's move to the next question. So here it is also a numerical based question. A metal undergoes the following two redox half reaction. The reaction is given, also the EH naught for these two reaction is given. What potential would be measured if a cell with an EH naught was connected to a cell containing an electrode made of T in a solution of 0.1 molar T2 plus at 25 degrees centigrade? Assume RT by IF to be 0.02568. So also this question is based on Nernst equation, that we have been given the EH naught values for the reaction, and we have to find out the potential. So I'll give you all 5 minutes to just solve this question and write the correct value in the chat box. Please try to solve this question, because this question is very much similar to the previous one. So please try to solve and write the value in the chat box. Okay, let's see how to solve this question. So the electrode is made of the metal T solid. So the reactions are T3 plus 1 electrons and it forms T2 plus. And next is T3 plus and 3 electrons, it forms Ts solid. So the electrode is made up of solid, so we will reverse this reaction. This is 1 and this is 2. So 1 minus 2. So T solid will give us T2 plus 2 electrons. Since we have subtracted equation 1 and 2, so also the EH naught values will vary. So it will be EH naught will be 0.53 minus 0.87 because we have reversed the second reaction, so it will be minus 0.34 volt. So we have to find out the potential if the concentration of T2 plus is given as 0.1 molars. So we will write the Nernst equation. It is EH equals to EH naught minus RT by NF ln Q dash. So we have EH naught as minus 0.34 minus RT by, it was given that RT by F is 0.02568 and number of electrons is 2 into ln activity of T2 plus. Solid will have activity of 1 and electron is also activity of 1. So T2 plus has concentration of 0.1 molar, so 0.1. So after solving this, we will get the value of EH as so we are getting value as minus 0.3. So this is the answer. Let's move to the next question. So the question is, the predominance area diagram discussed in lecture 60 implies the different conditions at a range of pH or PE The diagram is useful for analyzing the conditions and determining the course of action for removal of toxic arsenic. Choose correct statement. Statement marks only provided. Okay, more than one options are correct. So the first statement is the spent sludge range as depicted is in oxidizing condition due to the applied potential to force a thermodynamically unfeasible reaction. Next is leachate stating in lower pE and pH ranges implies it can travel far distances without changing the concentration as arsenic is prevalent in arsenic 3 form, prefers to stay dissolved. Next is co-precipitation of iron solid as FeOH whole 3 with arsenic allows an easy removal of the same. Option D is the linear slope line in speciation suggests no involvement of H plus ions in the redox reaction. And the last option is Fe3 stays as dissolved for most of the ranges demonstrated. So these five are the options, and there was a pH diagram between iron and arsenic species. So based on that figure, we have to find out which of the following statement are correct. So please try to solve this question and write the correct options in the chat box. pH diagram which was discussed in lecture 60. So we can so the correct options are that is B, that leachate stating in lower P and pH ranges implies it can travel far distances without changing the concentration as arsenic is prevalent in arsenic 3 form and prefers to stay dissolved. So we can see that when P and pH value is low, so arsenic mainly in the form of HASO2, that is arsenic 3 form, and it stays as dissolved till pH around 8.5, sorry 8.5 to 9. So this statement is correct. Next is co-precipitation of iron solid as FeOH whole thrice with arsenic allows an easy removal of the same. So we can see that at the reducing conditions and at high pH greater than 9, the arsenic and iron solids are getting precipitated. Arsenic is complexing with iron and it gets precipitated out. So this is also correct. So these two statements are correct. That is B and C, and the rest three statement, that is A, D, and E, are incorrect. So these 10 questions were on the last assignment. So these were the problem set related to the all the 12-week course. So I hope
Madam, please tell me the 10 number question once again. Once again, show the answer.
okay, let me share my screen 1 second.
What was the questions first?
Okay. So this was the question, and I have
Yes.
shown you the area predominance diagram for iron and arsenic, which was discussed in lecture 60. So based on that, option number B and C are correct, that at low pE and pH value, arsenic exists as arsenic 3 form and it is in the dissolved form. And option C is co-precipitation of iron solid as FeOH whole thrice with arsenic. FeOH whole 3 co-precipitate with arsenic, and there is removal of arsenic at higher pH greater than 9 and very high reducing conditions. And the option number A, B, A, D, and E, these are incorrect. So I hope this question is clear. So do you have any other doubt? Okay, let me know.
Madam, BC and correct, nahi?
B and
BC,
C
right.
are correct.
B- BC is correct. Okay, okay,
Okay.
okay.
Okay. So, do you have any other doubt?
No, I have no doubt.
Okay. Okay. Thank you so much for joining. Most probably there will be one more session, maybe tomorrow from 7 p.m. to 8 p.m. So, if it will be tomorrow, then a mail will be circulated by tomorrow morning. So that will be the last session.
Hmm.
So thank you so much for joining. Have a nice day.
Thank you very much, madam.
Okay, thank you.
A nice presentation.